Hello, thank you, Gada, and good morning. So, well, carry on with the presentation. Obviously, apart from the different stacks that we have developed during the project, one of the key activities is the contact with ports in order to receive the inputs from the different port authorities, because at the end, this tool will be focused and is addressed to the port authorities, port facilities. So those stakeholders who know or who need to know what is the water quality. But when we talk about water quality, it's not only the different parameters. Also, we receive information from different sources, from against about the different parts of the emergency warning systems in order to recognize or identify oil spills, to model, and in order to anticipate and to prevent oil spills, and also the idea of the forecast weather in order to know exactly what will be the next steps in order to anticipate and to mitigate any problem. So in this sense, we have contacted during the first months of the project with different port authorities. We create a stakeholder advisory board in order to contact with them by different ways. Please, next slide, please. Then we have contacted. Perfect, thank you. So the stakeholder advisory board is formed by the Port of Valencia, Ravenna in Italy, Piraeus in Greece, and Melilla in Spain. So the idea has been a very short contact with them in order to receive their inputs. What are the main interests, the needs? So because the idea is to obtain or to achieve a useful tool in order to have information in real time from different sources, from the satellite images, and know exactly what is the water quality, taking into account the Water Framework Directive, and also how to anticipate and mitigate any oil spill or any emergency situation. That is the main action. So the next, please. So the idea here is has been to have these short contacts through the organizations or the head of different workshops, where we have received the information from these ports and other invitation ports that has been attending the workshops. Here we have analyzed exactly what are the main interests. We know exactly what is the state of arts. So when I say the state of arts means how is now the measures that we have at imports about to know exactly what are the parameters, the different measures, campaigns of the water quality, if we have sensors, what kind of sensors. So the idea is to have like an evaluation and assessment between what is the current situation at ports related to the water quality, and what is the added value of the HiSea tool in order to install this platform in a port. Also, other actions taken on has been the questionnaires in order to receive user needs. We have disseminated these questionnaires to different stakeholders, port facilities, port authorities, but also with regional governments in order to know exactly what is these interests. And in these user requirements, we have identified 4 scenarios, mainly 4 scenarios, taking into account the area control and monitoring to know exactly what is the water quality. As I said before, the early warning system, that I mean here the emergency situation, like an oil spills, and how to act to anticipate and to prevent. The modeling in order to know what exactly is happening in the next steps, and the method that we said here, that is about the forecast weathers in order to receive all the information as possible, the maximum information as possible. And the next, please. Here you can see in the next slide, you can see the different scenarios and the details and information that we have collected during the previous phases in order to include and taken into account in the HiSea Platform co-design. And here, I would like, at this point, I would like to give the floor to my colleague Mark, that is working with us in this project. Please, Mark.
Hi everybody, I'm just going to turn on my camera so you can see who I am, but I'll turn it off again so there's no connection problems. Okay, so thank you everybody, and I'm just going to go through the demonstration scenarios that we want to show after in the actual demonstration. Okay. Okay, so we have the user needs all from the workshop and the questionnaire. We have the user needs, which were translated into user requirements and are now put into scenarios to show how users can visualize using the HiSea platform. So during this process, the HiSea team realized that each port is unique with its own characteristics and its own needs, making this an important challenge to come up with a platform that fulfills every port's needs and expectations. In the following slides, I'm going to go through just some possible scenarios. So I'd like to invite everyone that has an idea or comes up with a new scenario that better fits their port or activity. So please feel free to send us your idea through the chat at the end or through via email, which we'll give to you later. So just bear that in mind. So the first one we're going to talk about is area control and monitoring. That's what we call it. So ports generally cover a large area of protected calm waters, and this makes it more of a challenge to measure the water quality of a whole area. The bigger the port, the more sample points, and the more difficult it is to represent. So exactly, and more so to obtain a value that represents the entire area. So measuring campaigns are normally carried out during the year, every other month or so, depending on the port. In specific points in which value represents the entire area. 1 second. So it's impossible to measure every part of the water every day. So what we are achieving is to eliminate gaps between campaigns and incrementing sampling points, providing precise continuous measurements to be able to monitor any point and any area inside or outside the port. So this will allow a port to characterize their waters at any time of the year and not just in specific sampling points. So this will also benefit the port in the sense of complying with water quality regulations, because they'll be able to know whether they are within the regulation limits at any time and not just when the campaigns are carried out. Of course, there's also a delay between when the campaign is done and the results are received. We all know that the trend is for regulations to become more and more strict. So it's a way of staying on top of what the ports, what's going on with the port's waters. So next, please. Thank you. I'd like to point out that the platform is currently under development, so we could say that it's alive and changing for the better. So it's we're continuously improving and setting out different scenarios to try and see how it can fit in different ports. So that's why your information is very important. Okay, so second, we are working towards developing an early warning system, as Rafa mentioned earlier. So the idea here is that if the platform detects, or the idea is for the platform to detect at an early stage an abnormal value for a specific water parameter, say any water parameter outside a specific limit, depends on each port. Then it notifies the user to help streamline planning operations of any actions that need to be carried out to control the situation. So for example, the system identifies a spill of some sort, say oil. Then the early detection through satellite imagery can help the port take action as quick as possible to carry out cleaning operations, reduce spreading, and avoid causing further environmental impact. So this especially comes in handy when low visibility comes into play, for example. You see in the images above, eagle eye views, just two things to point out. Eagle eye views, as you can see on the image on the right, are very easy to pinpoint, especially with a clear day, to pinpoint oil spills, for example, or any other type of spill. But on the contrary, when you're at water level and it's low visibility, it's much harder to pinpoint. So a tool of this with this type of functionality can be very handy for operational, cleaning planning processes. Next, please. Thank you. Next is modeling. So data modeling is the third data source that we are integrating into the HiSea platform, as Heather said in the beginning. So at the moment, we're working on 3 types of modeling. I'm going to start with forecasting. It's the third one that's in the table, with forecasting water quality parameters. So how would this benefit a port? For example, if the port of Melilla, let's say, is interested in monitoring turbidity, and they wish to foresee this parameter's values, then that would be possible with this type of modeling. It sees X amount of time in front of, depending on the historical values and the current values, it will model the future. So the user could foresee whether a parameter is about to exceed regulation limits. And this would help the port prepare for any required actions needed. Second, water trajecting models. This one is focused on spills, mainly. So for example, an oil spill again. Once an oil spill is detected, the system will take into account the hydrodynamic parameters and it will forecast the movements of the spill. So these type of situations can be extremely hazardous in bad weather conditions and with low visibility. So the benefit to the port is to help streamline cleaning operations and reduce any environmental impact. Obviously, many others, but that's the main objective here. And thirdly, we have what we call backtracking. So this consists of parting from sort of the reverse exercise as number 2, which water trajectory models. So backtracking, it consists of parting from a late identification of a spill, for which the system will simulate the reverse tracking of its spread in order to find the source of the spill. So this could help identify the source of illegal spills and also the ones caused accidentally. So, I mean, you can see in any of the different situations that I've said that there are many more possible situations for each of the tools. So that's where we invite you all to try and put together any ideas that fit better in your port and your daily activities. Next, please. Thank you. And finally, we have a functionality that provides ocean conditions and forecasting of hydrodynamic parameters and wind. So although it isn't directly related to water quality, we thought it's interesting to have all this information on one platform. Met ocean data is always handy for ports for operational planning, especially under bad weather conditions. For example, maintenance for infrastructure and port infrastructure.